Record the session. Okay. So as per our syllabus, we have completed until CACD, and then we just moved. We just saw some of the AWS concepts also. So today we'll just jump to Docker, which is a containerization tool. So do you guys have any idea about what is Docker or what is containerization of applications like that? So any idea? Sorry, I was talking without unmuting the mic. Okay, so do you guys have any idea about what is Docker or what is containerization?
Docker is used to build
Build image. Okay.
yeah, build images and applications in containers.
Okay. Okay. So Docker, say containerization is a process of doing something in an efficient way, in a very lightweighted, very portable, and also you can easily accessible from anywhere. Okay, so these are the very main three characteristics of containerization. So Docker is nothing but is a containerization platform which helps developers or DevOps engineers to package the applications. Okay, so this is overall. You just think in a way like you have a container, so inside the container, you will be putting whatever the things you want. Okay, like that. In our case, you have a container. Inside that container, you are putting like a package of your applications, your application dependencies, and also the services whichever you want to run for your application. Okay, so tell me this. So you guys have the same thing is happening in virtual machine itself. So why we going to container? So we have applications running in our EC2 instance. We can able to run that through our computing resources which was already available in AWS. So why we need to go to another platform which is called a containerization tool. So why we need it? What is the purpose of? What is the difference of these two things? Any idea? You can say. You can just try to say something.
It, to make it more simpler and easy to maintain.
Yeah, very good. Also, okay. Any other answers?
So inside the container, we can put all necessary items to run our application. So we
Hmm.
can run it anywhere, no matters where we run our applications, like the environment. But in virtual machine, we have to run only in that machine only. But we have to run that in another machine. It raises some problems like dependencies, versions. So these kind of problems are not arised in containerization application.
Exactly, exactly. So for these things, we just moving to containerization. Okay. I'll just show you one diagram, a simple diagram to understand. Just 2 minutes. So, okay, I'll just share my screen so that you can have the understanding of what is Docker architecture. Okay, so between that, I'll just give you theoretical explanations for what is containerization, what is platform, how it works, and what are the components it has. So we'll just complete that, and I'll just go to the Docker architecture, which is main thing that you want to understand. If anything, if any doubts, you just stop me there and just ask the questions. Okay. I'll just share my screen. So my screen is visible for you, right?
Yes,
Yeah,
Soumya.
Soumya.
Yeah, okay. So this is the PPT which I already shared with you guys. We saw the Terraform workflows and the DevOps tools explanations. So the same PPT, I'm just opening here. So the first thing is introduction to Dockers. Okay. So why we using virtual machines? See, we have our own on-premises or a physical machine itself, but why we using virtual machine? Okay, like try to say like this. What are the advantages of using virtual machine? Anything that is related to the answer, you can try.
It saves us space and the amount for maintaining a physical machine.
Yeah, exactly. Any other answers? So by using virtual machine, you can use the full resources and you can utilize the full resources, full storage inside your virtual machine also. So which is secured, and also you don't want to pay the full amount or full price for your physical machine or hardwares or something, and also you will be have some people to maintaining your machines, and you have to be monitoring each and everything. If it is happening, if it is going to happen any downtime, or if it is going to happen any crashes or like that. And also if you want to scale your physical machine, means you have to buy some extra storage or you have to buy some extra machines. But in virtual machine you can scale your storage, you can scale your machines also through auto scaling. You can scale that through load balancer. You can just control the traffic, and also it will be distributed equally if you scale your machines according to that. So there are many features and there are many things you can do with virtual machine. And also virtual machine, you will be having operating system in it. So see, in virtual machine, the operating systems storage and the pack, the size is almost to 2.2 GB. Okay, but in Docker image you're going to use a host operating system, which means you're not going to use the full heavyweight operating system. Instead of that, you're just going whatever the sufficient amount of things you need, you're just going to take that only. So it is lightweighted, and also you will be have images for that. Images is nothing but it's a pre-built template, or it's a pre-built image that you can download and use that on your application. Okay, so that size is not it's 20 MB or 22 MB, like that only. So according to 2 GB, it's 100% less storage, 100% less capacity of holding very much what to say, holding a lot of weight to your application. It is reducing the size, and it's just making it as lightweight and portable. Okay, so this is the very main thing you have to be keep in your mind if you think of containers. So we have virtual machine, we have our physical machine also, but why we are moving to containers? The very first thing is we are not using the full operating system. We are just having the limited amount of operating systems that you want to use for your application. Okay, So, second thing, you will be having a consistent environment. So, consistent environment is nothing but, say you have your container, inside that you will be running your applications. You can think in this way. So, if you want to do anything to your applications, means you need to do that on your own, or you will be going to attach something or creating something to your application to run to run smoothly for the high performance. But in Docker, but in containers, everything will be taken care of an orchestration tool. Okay, why we are going to an orchestration tool? We have container tool, container platform. So inside the container platform, we just having our applications running very smoothly and everything is fine. But why we going to have a help of an orchestration tool means nothing but containers or Docker having main four disadvantages. Okay, so the first thing is it is ephemeral in nature. Ephemeral in nature is nothing but it can easily kill at any time. It's a short live. Okay, second thing, yeah, I'll just add that on notes for you. So Docker, lightweighted, portable, loose host operating OS. Okay, so these are some of the explanations you can give whenever someone asks you what is containerization, what is the purpose of doing that. Okay, also you will be having pre-built images. So no, you can create your own image, and also you can download images from Docker Hub. Also Docker Hub is nothing but many images will be stored on there. Okay, there are more images, thousands of images have been stored there. Whatever your dependency, whatever your, see, now you want to download Jenkins, or you want to download Nginx or something to your application, means you can just go and use the image. So the image will be so that images consist of all your dependencies for your application. Okay, so the main reason is we will be having this global problem, like see, something is working in my system and it's not working to the another's one, or see, developers in developer system it's working, but in operation system it's not working, means they will be end up with some dependencies problems, version problems. See, as I have told before, my system is kind of having another OS, another versions compared to the another person. So in my system, I will be having the dependencies and it will be working fine for me. For the another person, they should have download every dependencies, and it's a manual work. It's not efficient work. So it will be time consuming. For that purpose, we will be giving this image. I just stored this image into my repository, into my Docker Hub, which is nothing but you can think like a GitHub. In GitHub, you are storing your codes, but here you will be storing your images. Okay, so the another person will just pull the image from the Docker Hub and he will be going to use that, and also it is going to be work fine to him, because he have the entire dependencies to run the application or to run the services successfully. Okay, do you guys understand this?
Yeah, Soumya.
Yes, ma'am.
Yeah. Okay. Okay. So I'll just talk about the disadvantages now. So the first thing is it is ephemeral in nature. So which is nothing but it is short-lived. It can kill. It can kill anytime. Okay, it can kill itself anytime. So second thing is not provide you auto scaling. Third thing, it will not having auto healing properties. So I'll just elaborate this, and finally, it will not support you enterprise level. Enterprise level. So these are the very four important disadvantages of disadvantages in Docker. See, the Docker is giving you a very good feature, a very good process of doing your application to run very smoothly, and also being taking it as very lightweighted, and everything is taken care of. Everything is doing by, you can do that by Docker. But disadvantages is, if your container, see, you build your image, and then you're just using your image, you're just running your container. Okay, so inside the container your image will be going to run. Okay, or your application will be going to run. So in that case, see, you can't, if you're using that in production, means it can kill anytime, means you will be loss of data, you will be loss of your application, and everything will be collapsed. So in that case, if something is happening to it, means it cannot auto heal. Okay, there is no feature of Docker that we can assure it can be auto healed, not like that. So second thing, if we meeting any demand, if there is any demand reached, means it will not auto scale. See, if we have created a one container, means it will be going to remain as one only. Okay, and also according to these all things, how can we use this in a real production team? So we can't do that, right? So it can kill anytime, it is not going to have any auto scaling or auto healing. So these are very important disadvantages that Docker is having. Okay, so coming to the point, for these four things we are having, and we are just going to rely on an orchestration tool. Orchestration tool, do you have any idea about what is orchestration, or which tool we can use for orchestration like that? Okay, so we are using Kubernetes. So using Kubernetes, what Kubernetes will do means it will manage your containers. Okay, Kubernetes will take care of the containers, and also, see, whatever the four disadvantages we saw here, Kubernetes will solve all the four disadvantages, and also not only four disadvantages, there are many disadvantages being there, but very noticed and very important disadvantages and important things is these four only. Okay, so in Kubernetes, CVC, it's ephemeral in nature, but we will be having a concept of pod. Okay, so pod is nothing but how your application is running inside your container. Here, your container is going to run inside a pod. Okay, it's a wrap over for your container. So it will not kill itself at any time. If something is happening to that, means pod will do the auto healing. So it has a auto healing properties. So it will never let your container, never let your pod uh, to destroy itself, or any things happening wrong, means it will not going to allow that. Okay, it will do the auto healing things. And also, if you're meeting any demands, you want to have something, you have to do something for your application, means the auto scaling will also provided by Kubernetes. Okay, so here we will be having horizontal pod scaling. Okay, using that your pods will be scale out. So finally, using these things, the enterprise level support will be given now. What is provided. Okay, so you guys understand and have the difference between what is Docker, what are the some disadvantages it have, and how we are just having the solution for that disadvantages. So these things you are clear, right?
Yeah, Soumya.
Yeah, okay. So these are all a very so linear form of theoretical things. You just try to cover it on your free time. So I'll just give you an overview and the workflow things. Okay, so container is nothing but you are running your process services or your application inside that, using a form of image that you are going to build, or it is already built in Docker Hub. You can just use the pre-built images also. So it is isolated process. So it's a server is running in isolated environment also. Okay, you don't want to worry about so I'm leaving it to the cloud, so what will be happen, so you don't want to have that worry about everything will be isolated only. Okay, and also you can use Kubernetes to entirely partition the pods also. So so as I told already, it is enterprise level support. So you will be having a very main and good features on that. So it's portable to anywhere. Yes, it's lightweight OS because it's not using the whole OS. And then it contains and packaged required binaries and libraries. As I told with the example of working in one system and it's not working in another system. So on that scenario, we will be having this binaries and libraries, which is already inside the image. You're just pulling that image and just running your application. Okay, and then you will be having the required dependencies. See, if I'm having Python, if I'm downloading Python, means whatever the latest versions, latest dependencies, everything will be inside the image. Okay, yeah, you can run multiple versions of the same application. How can you achieve this multiple versions of the same application? So I'm just creating one application and I'm just pushing that to my Docker Hub. Another thing, if I want to do any changes to my application, anything means I will be doing again and I will be just pulling that to my Docker Hub. So here the version control system is also achieved here, like how we doing in GitLab. So the code is being there. If you are doing any changes in your code, means each and everything will be recorded on your GitLab, or it has been placed on your GitLab. So according to like the same thing, we are having the version control system for your images also. So obviously I told that it's ephemeral in nature. So these are some things. You just try to study this. Okay, we'll just talk about some important terminology, some important words or components. Okay, so containers. So containers is lightweight and portable, which is executable units also. You can push that to your Docker Hub, and whenever you want, you can pull that to your to your real what to say, if you're working in any project, if you're not going to run that in particular time and you want to going that later, means you can just store that on your Docker Hub and you can use that at any time and anywhere. Okay, see, if you are here, if someone from US want to access that application, means you can just share the credentials, and also if it is public, means you just share the link to them. They will be able to pull that, and they can easily see the application, or they can easily access that. So images is nothing but it's immutable templates used to create containers. Okay. So as I already said, once you create your image, you're just going to save that. After, you can make the versions of your images. You can go and edit your image which is already created. Okay. So that is what we call the immutable templates. So as I told before, you will be having your application dependencies, everything inside your images. Okay. See, here it's an example. In virtual machine, you will be having AMI. So what is AMI? You guys already know that, and you have prepared what is AMI, launch template, and snapshots, everything. So what is AMI? So AMI is a template for running your EC2 for taking the template of your EC2 instance, or AMI is provide you the operating systems. If you want to go for Red Hat or Ubuntu or Amazon Linux, you just going to change your AMI. So that's it. For like that, in images, you will be going to change the images according to your dependency. Then Docker file. See, Docker file is nothing but in GitLab CI YAML file, which is the file, executable file that is triggering your pipeline. Here you will be going to have a Docker file. So inside the Docker file, you will be writing the scripts, like how we used to write a script for Terraform scripts to execute the work. Here you're going to write the things like I want to create, this is my application. I'm copying the application from here. So it's a, what to say, it's just a set of instructions to your image. Okay, so that is what you're writing inside your Docker file. So the Docker file, you will after writing a Docker file, you will build a Docker image. After you building a Docker image, then you will be having your container, and also last you can run your container. Okay, I'll just show you that. So this is the Docker workflow. See, the developer is being here. He will write a Docker file, and the Docker file, using the Docker file, you will be creating a Docker image. Okay. So Docker image is nothing but a Docker container. You're just creating a Docker container using that image. So you can store your Docker image to the Docker hub, and then you can make it available whenever you want. Okay. Or else you can make the Docker image to a container, and you can run the container now also. So this is a simple workflow of how Docker's life cycle and how it workflows happening. So is that clear?
Yeah,
Yeah.
Soumya.
Yeah. Okay. So this is how Docker workflows happening, and then Docker Hub. So you know that it's a public or a private registry that you can store your images there, and also there is many kind of images there, and many so thousands of templates. Sorry, not templates, thousands of images there. If you want to pull any of the image, you can try that using Docker pull command. If you also, you can also create your own image, and you can push that image to your Docker hub also. So it is a registry for your Docker images where you can store your image, and it can also be shared. So volumes is nothing but as we told before, it's not going to access the whole operating system. So it is going to have some point of operating systems only. In volumes, if you want to if your data, it should not be lost, if it should not be lost, right? Because it's ephemeral in nature. You're running a container means you will be lost that if it is crashed or killed itself, you will be going to lose your data. So if you attach volumes means it is a file system, it will be going to attach with your container. So the data will be stored on a particular volume. See, if a container is failed, if your container is crashed, it's no more means you can also have the persistent data with the help of attaching the extra separate volume. Is that clear? So nothing but there is we are not having the volume inbuilt. We are attaching volume to that container. If anything happened to the container means we will be having the data which will be not lost. Okay, we are just having that as a backup in our own volume which is attached to the container. So simple. Then process ID. These are all some commands we will be using in Docker. So ps-eaf. This is nothing but you're just listing the Docker images or listing the container. Not images. You're listing the container. Okay. So these are all some advanced concept. We will be looking that in a practical way. For now, if you want to download HTTP means you will be running these commands. But here you can just copy, you can just pull your HTTP, Nginx, Python, Java, whatever you want, you can just pull that from your Docker registry. Okay. So as per I told, what is Docker registry and what is Docker hub? Any idea? So Docker registry, it is a public registry. Yeah, yeah, Manoj.
It stores what we created, like the images.
Yeah, exactly. So there is two types of images, right? Which is with the one thing we created, which should be private for us. The another thing is always already available in
Available
market.
Docker.
Yeah.
Yes.
So in both cases, which is Docker Hub and which is Docker Registry. Okay, so Docker Hub is what we created. We will be storing that in a Docker in a Docker Hub. So you will be having your own credentials. You will be making it as a private registry so that no one can access into your image, or no one can do anything on your particular private registry or private registry. So the private registry is called as a Docker Hub. Okay, so public registry is nothing but, see, if you want to, you can simply go to your terminal after downloading a Docker something. You just go to your terminal and you just give Docker pull Nginx or Docker pull Python, means the image will be pulled to your account. So how it is happening? Because of the public registry. Okay, so it's already in there in a Docker public registry. So it is pulled over to your local. Is that clear?
Yeah, Soumya.
Okay. So like that only we are doing that. So Docker Hub is private registry, like you can think in this way. It's a private registry. You can make it as public also. But for your understanding, I'm just telling that. Okay. So Docker registry is a public registry where you can push any where you can pull any kind of images that you want. So these are some of the theoretical things. You just try to just study and just get some idea about that. And this also, what is virtual machines, how virtual machines are just comparing the virtual machines and Docker platform. Okay, I'll just show you the diagram of that, so that you don't want to worry about the very theoretical parts here. You just try to read one or two times, you will be getting some idea. Okay, so I'll just share you the Docker architecture. So this is what a Docker architecture looks like. Okay, it's a high level overview of what Docker is doing. So you guys know Docker workflow is nothing but you will be going to write a Docker file. Using the Docker file, you will build an image and then you will running your container. Okay, so here it will be it is just separated as three components. So first thing is Docker client, which is nothing but you can think that you are doing something. Okay, so Docker client is nothing but you. Okay, so Docker host is the thing. Whatever the commands you're giving from CLI is nothing but your git bash. Okay, so you want to build, pull, run your image, whatever the commands you're providing here, that commands will be, that request will go to a Docker daemon. Docker daemon is nothing but a background process of running your request. Okay, so after that, you will be having containers one side, and you will be having images also. Docker host is nothing but in the remote type. So client you think in a local, and Docker host you just think in a remote. Okay. So whatever the comments you give, it will be reaching to Docker daemon, and then only it will be going to the various components also. If it, see, I'm going to pull something images, means it the images is not here. So the images will be in a public registry. So the pull command goes to Docker daemon, and the Docker daemon goes to the registry and takes the image, and that image is storing inside your remote, and then it's going to deliver you whatever the thing you want. Okay, whatever the image you want. So this is how we are using the CLI from local to remote to the public registry. Or you are going to give the commands here, which requires only Docker host, means it will just communicate with here. Okay, it's here it is a Docker build, pull, run, but you will be having many different kind of commands also. So according to that, everything first reaching to Docker daemon, after that only it will be reaching to images, or it want to create a container, means everything will be doing after. So you understand this, right? Any doubts on architecture, anything you want to ask?
No, Soumya.
Okay. So another one thing I want to show you guys. Okay, just share it. So here difference between Docker and VM. So this is another one main thing that you have to keep that in your mind. I just lost the PPT, so that's why I'm just going to Google and getting the diagrams. I'll just take the PPT and I'll share that to you. Okay. So you can see that container versus VM. So as I already told before, we having virtual machine to run a application. So why we going to container means here is a very neat explanation for you guys with the comparison of the diagram. See here you will be having a container. Okay, this is a container based deployment. So here this is a virtual machine, so it's a VM based deployment here. Okay, so we running our application in our physical system, and also we are running that same application in a virtual machine, means they will be they both doing the same work only. So the extra things that VM can do is it will scale your application, it will do some of the important like load balancing, healing, auto scaling, high performance. So these are the a very good features that is attached to your VM. So when you compare to the size and when you compare to the things with your on premises and with your VM, means it is doing the same. When you compare to the size and the exact works, whatever doing from your physical machine, you're just logging into your VM and you're doing from there. Okay, so in that case we will be having Docker image to make your application more its application in a very portable, very lightweighted, and you can access from anywhere. So here if you are having your application in your VM, means you will be having that in your VM only. You have to give some DNS or some port mapping, sorry, not port mapping, you have to give outside access. So here not like that, you can access it from any kind of systems, and also not one or two people can access any kind of people. There are number of peoples can access the access your containerized image or containerized application at anywhere. Okay, so here you can see that we are having the infrastructure. So on behalf of that, you will be having hypervisor. You just see the virtual VM based deployment. You're having infrastructure. On behalf of that, you will be having hypervisor. Hypervisor is nothing but you can able to run your virtual machine. So using hypervisor you can do that. Okay, so on behalf of that, you will be having guest OS. So you are yourself having an operating system in your VM machine. Okay, so the operating systems is fully using here on that. After that only you're going to having your Docker engine. Docker engine is nothing but you're just running your Docker environment. Okay, so after you installing and running your Docker engine, then you will be having your binaries and the application which is inbuilt inside a container. Not inbuilt, you are going to run the container in your by using of Docker engine. Okay, so here also if you want to scale your application, or if you want to run any another kind of application, means you can do that. And after that you will be having binaries. So this is application dependencies. Okay, this is Docker, and you will be having Docker dependencies. Here you will be having full OS operating system, and this is for application, this is for system dependencies. So you will be having many kind of you have to download many kind of dependencies, and you have to worry about the paying for whole OS, and also it will be going to make your system, make your deployment a little bit slow. And also when you compare to container, it is somewhat disadvantage, okay, or somewhat you're doing in a very long process. So here, if you go and see the container-based deployment, you'll be having infrastructure. It is using host OS. So a limited kind of OS it's going to use, not a full OS. Okay. And on behalf of that, you will be having Docker engine and your applications. Okay. So you don't want to run the system dependencies. You don't want to run get the whole OS and making your application looks more weighted. So doing this, it can be you can be having a less size of your application, and which is you can store anywhere. You can download that anytime and anywhere. So these are some extra features, extra advantages of using containers. Is that clear?
Yes,
Yeah,
ma'am.
Soumya.
Yeah, okay. So the another image. So whatever I told to you guys, I'm just going to show you as a table format. So you can see that this is virtual machine and this is Docker. Okay. So each virtual machine runs it on. It's taking whole OS, but here it will be having host OS, and here you have so see your container can itself initiate in it can itself it's refresh and initiates, but here in virtual machine you have to what to say, you have to restart your computer, you have to restart whenever you made any changes to that. So simple things only, but it is making your time it's very low time, and also it is very efficient, and everything doing in a little bit of automated way. Okay, so it's reducing a manpower again. So virtual machine, we have to take the snapshots, right? You guys know what is snapshot. So it's a backup for your EC2 instance, or it's backup for your resources. But here you don't want to worry about backups, because you having your image which is stored on your GitHub. Sorry, which is you storing on your Docker hub or a registry, right? So it's like a snapshot, or it's like a backup acting on your acting for your image. Okay, so no version control, sorry, there is no version control available, but here you can have version control system, because as I already told, Docker hub is where you can store your images, like how we store our codes in GitHub. Okay, so again, you cannot run more than couple of VMs on an average laptop. Yeah, so you will be restricted to your VMs. If you see you have virtual machine, inside that you will be having a number of VMs can be created. But in Docker, you will be not restricted like that. You can have any kind of many kind of Docker images or Docker containers you can run using the help of orchestration tool. You can scale up your containers, you can auto heal your containers, you can do you can have a very high level enterprise level support to your containerization and to your applications. Okay, and then here VM can be started from one set of VMs and VMD. Okay, so here you will be having every files inside your virtual machine. So but in if you have whole operating system, you will be not going to use the full resources or the full files. But in Docker container, you will be having a limited amount of operating system. From there you can save your data. If you want data persistence, means you can create a volume and you can mount that volume to your container also. Okay, so you guys clear from the Docker introduction and how Docker works, Docker workflows, and the architecture of Docker. So what is Docker daemon, Docker hub, Docker registry, Docker file? So these are the main components that you have to know. Okay, so you have some idea about what is Docker and how it doing, right? Is that clear?
Yes, Soumya.
Okay, any doubts, Manoj, Sabita? Any doubts? Okay, so today I gave you basic to high level explanation of how Docker works, Docker doing. So you just go and look at more videos or more learn on your own about what is Docker, how it is. How we using that in real time. So there will be plenty of things we have to learn in Docker. But we will be covering whatever the main things you want to know, whatever the things or the key components, the main keywords that you have to tell to your interviewer. So these are the things I'm just covering to you. So I'm very focused on that, and I'm just whatever the topics I'm taking, I'm just telling you guys these are the keywords that you have to mention. If you are saying Terraform means you have to mention the word as a infrastructure as code. It's a configuration management or creating resources like that. I'm repeatedly telling that you guys take a note on that and just try to add some more detailed explanation for your learning purpose. Okay, so that it can be easy for you guys to learn and recall what so far you have learned, what so far you have seen in the DevOps tools and DevOps concepts. Okay. Okay, guys. If you don't have any doubts, means we can wind up. You just go through the recordings. You just go through the some materials which I will be sharing to you. So try to learn well and try to learn more concepts on Docker. Okay.
Okay, Samir.
Yeah, sure. Okay, guys. Then we can wind up today.
Thank you,
Okay,
ma'am.
Soumya. Thank you, Soumya.
Yeah. Yeah. Thank you, Manoj. Thank you, Sabita. Bye.
Bye.
Bye. Bye. Bye.